Alright, so you guys had to learn about EKG, which is the electrical signals through the heart. So we're going to go through first how those electric signals move through the heart, and then we're going to talk about an EKG and the waves, and then we're going to talk about the problems that you can see from an EKG. So first, let's talk about the signals. So there's three main parts. There's the SA node, AV node, Purkinje fibers. All right, the SA node is probably the most important because it controls the heartbeat. So this is the first thing that happens, and then its signals cause the other two to go. So the SA node, you see how there's little arrows coming out of here? That's because it's then signaling. Here's the AV node is going to signal the AV node to do its job, and then the AV node sends signals down to the Purkinje fibers to do its job. So the SA node controls the heartbeat. It basically sets the pace. It's a natural pacemaker. All right, so I'm going to put pacemaker up here. All right. It also then causes the atrium. So when this goes, not only does it send signal to the AV node, all right, but it also sends signals for the atrium here to contract. All right, and when that happens, we get a little blip called the P wave, which we'll talk more about next time in the next section. And that is just basically that signal, that pulse from the atrium contracting. Then the AV node receives that signal and sends it down to the bottom of the ventricles, and then it goes to the Purkinje fibers, which go up each side of the ventricle, and that causes the ventricles to contract. All right, so the ventricles are contracting. So that is shown by this wave right here, the QRS. And you notice how much bigger this wave is to the other one, and that's because these are stronger muscles, so there has to be a stronger impulse for those ventricles to contract. All right, so that is the SA node, AV node, and Purkinje fibers. So now we're going to go to the waves here. So we already talked a little bit about them, but we'll talk about them again. So the P wave, this is when the SA node goes, and this is the atria. All right, that's the atria beating. The QRS, our next one right here. This is the Purkinje fibers and AV node, and this is the ventricles contracting. Alright, and then the T wave, we didn't really talk about this last time, but the T wave is the ventricles relax. Alright, so you get that little electrical blip when the muscles kind of relax to get ready to pump again. Alright, so now looking at this, the reason why this has a U wave and some other stuff on here that you don't need to know, you just need to know those three essential waves. But another thing I want you to realize is that this is one beat of the heart, so it goes through that whole pattern once, and then it will start over. So this is beat number 1, and this is beat number 2. So to figure out the pulse, you can figure out the pulse from this, is we can look at this R to R interval. You don't have to worry about what the R to R means, but look at the time. This is when this here the ventricles contract, and then the ventricles contract again. So if we find the time here between these two, then we know how fast your heart is beating. All right. So if we find that this interval is 0.5 seconds, all right, then all we have to do is divide it by 60 seconds, and we'll find that we have a heartbeat of 120 beats per second. All right, because for every second there's going to be 2 beats, and in a full minute there would be 2 times 60, which would be 120 beats per minute, not per second. All right. So that's how you're going to get that into. That's how you can figure out the pulse from this. All right. The last thing I want to look at is the how does this relate to blood pressure? So we just talked about how it related to heart rate. Let's see how else it relates to blood pressure. So for blood pressure, remember there's systolic and diastolic. Systolic is when the heart is beating. So the heart is beating basically from this P wave here to the QRS. So this is the systolic. And then the diastolic is when the heart is at rest. So that's from here basically to the next P wave, when the heart is at rest or resting in between the beats. Alright, so this is when the systolic would be measured, and that's when the diastolic would be measured. So that's how it relates to blood pressure and heart rate. Alright, so just kind of putting those two together. Alright, so now the last thing we want to look at is, okay, so what can this tell? This is a normal heart rate, but so what can this tell you? Obviously, if this isn't going, that can tell you that the heart's not beating, and meaning the patient's dead, but there's some other things that can tell you, and we're just going to talk about two of them. You're not going to have to remember these words, but I want you to be able to recognize it. So, this, notice how our QRS wave is still pretty good. Alright, so we still have our QRS. We still have about a normal rhythm. Alright, there's about the same time between these, but there's a problem here with our atria. Alright, look at our P wave. There's like a double hump here each time. So that tells me, since the P wave is controlled by the SA node, there's probably something wrong with the SA node, which means that the atrium are not going to be contracting. It's still sending signals to the AV node, but the atrium are not causing contraction. So what this is like a heart murmur. Your atrium are like beating a couple of, like kind of fluttering. So they're not fully beating, so all the blood isn't going to leave the atrium into the ventricle. Alright, and that can be some issues. So you would fix this, obviously, with a pacemaker. Alright, so then you would get one solid P wave here, because that pacemaker would step in and take the place of the SA node. Alright, but basically what have to figure out that is, if you know this wave is the SA node in the atria, then you know that that's what's wrong. Now this next one, here's our normal wave up at the top, and then first degree heart block, there is not much of a difference here. So let's look at the second and third degree. I'm sure there is a difference here, but I'm not an expert enough to know. Second and third degree here, notice how there's P waves here, but there's no QRS. Alright, so that tells us that the SA node is working fine, but there's something blocking the AV node. Alright, because there's the P wave that is beating, but then the QRS isn't going, so that means the ventricles aren't pumping, and that's really bad. That means you're basically skipping a beat of the heart, and you're not going to be delivering the right amount of blood flow to your body. Alright, and that's because the AV node is damaged. This is usually due to damaged tissue in the heart, possibly causing a heart attack. Alright, so again, if you just realize, oh, the P wave is the SA node, that's fine, but the ventricle is not beating, then you know that there has to be something wrong with the AV node. Alright, so if you can interpret those, then you'll be good for what you'll need to know in this class. And if you decide to go into health professionals, at least somewhat of what you'll need to know.